As already mentioned, your multimeter can be used as a volt, amp or ohm meter. In this next section, we shall discuss uses for the ohm meter functions. Of paramount importance when using any ohm meter is that it can only be used on a dead circuit. If any voltage or current is in the circuit on test, then you will usually destroy your meter. The ohm meter function is selected by rotating the function switch to any of the ohms positions on the analog meter, or to the ohm symbol on your fluke digital meter. The primary purpose of an ohm meter is to measure resistance, and perhaps the best way to get started is to actually measure objects which have known values, such as ceramic resistors. Using the fluke meter, we can simply measure the resistance by clipping the test leads across the resistor. The reading will be the actual value in ohms. The meter will automatically range between low value up to several mega ohms. The value rating of this resistor is given as 1 kilo ohm, or 1K. The fluke reads it as being 992 ohms, which is a typical reading. Let's check the same resistor using an analog meter. Before we begin to measure, we must first set up or zero the meter. Keeping it flat on the work surface, select the ×1 ohm position and firmly join the test probes together. The pointer will swing across the scale face towards the 0 ohm figure, which is the top scale on this meter. Note that 0 ohms is on the opposite side of the scale to 0 volts or amps. In most cases, the pointer will settle somewhere off the 0 line. Keeping the test probes joined firmly, adjust the pointer position by gently turning the ohm scale adjusting wheel until the pointer lies directly over the 0 ohms scale division. Should you find that you cannot get the needle to come to 0, then the problem may be caused by A. Poor contact of the test probes, or B. A flat battery in the meter itself. In either case, the situation should be remedied, which will be discussed under care and maintenance shortly. Having zeroed the meter, measuring can now commence. Again, clip the test probes across the 1K resistor and note the reading. Here you will see that the pointer has settled virtually in line with the 1K line. However, it is impossible to provide pinpoint accuracy. To obtain greater accuracy, we can switch to the 10 position, re-zero the pointer calibration, and take another reading across the resistor. This time we see that the pointer has settled just before the 100 mark. In fact, the actual division is as close as can be to 95. But, as we have selected ×10 on the selector, we must multiply the scale reading by a factor of 10, which, in this example, gives us a result of approximately 950 ohms. You are by now becoming aware that operating and reading an analog multimeter requires more attention to detail. Let's briefly summarize the important points. 1. The meter itself must lie on a flat and level surface. 2. Select the particular function, for example DC volts, AC volts, ohms, etc. 3. Ensure that the pointer is resting over the 0 mark before connecting leads to the test piece. 4. Always observe the pointer from directly overhead so that you do not see the needle reflection. 5. When using the ohms scale, clip test leads together and adjust the pointer to read on 0 ohms. Readjust the ohm scale reading to 0 every time you change the position of the function selector switch between ohms expansion scales. When you've completed the job, return the function selector to the off position. Practice using your multimeter to measure resistances in electrical components, but always make sure that there is no voltage present. After the break, we shall discuss care and maintenance of your multimeter.